All right, this is the review unit 3, angles and triangles and congruent triangles video. Make sure you have your packet out so you can follow along with our video. Number 1, hold on. Number 1 says triangle ABC. Triangle ABC has angles that measure the following. A is 5x minus 1, B is 2x minus 8, and C is x plus 7. I know that all three of those angles have to add up to 180, so I do 5x minus 1 plus 2x minus 8 plus x plus 7 equals 180. Combine all my like terms. Eight x minus 2 equals 180. Add the 2, so I get 8x equals 182, and then divide by 8. So I get that x is 22.75. Then since it's a decimal, and I want to make sure I don't mess up my calculations with my decimal, I'm going to go into my calculator and store my x value as x. So then I know that whenever I type in x, the calculator knows it's 22.75. So then I'm going to use that to find a. 5x minus 1, and I can use x because x, the calculator knows x is 22.75. So I know that a is 112.75. B, 2x minus 8. B is 37.5 degrees. And C is x plus 7 to give us 29.75. Or I can plug it in and actually do it by hand. But using your calculator will help you, and you use it, whatever help you can find. Number 2, I want to find the measure of each numbered angle. So if I start from number 1, I know angle 1 would equal whatever 180 minus 40 plus 90. So that's 180 minus 130. So angle 1 is 50 degrees. Angle 2 is vertical from 90 degrees, so I know angle 2 has to be 90 degrees. For angle 3, I want to do 90 plus 48, which is 138, and then subtract that from 180 to get the angle 3 is 42 degrees. Angle 4 makes the line with angle 3, so 180 minus 42 gives me angle 4, so angle 4 is 138. I also could have used the angle 4 had to equal 90 plus 48. My exterior angle has to equal my sum of my two remote interiors. Angle 5 is vertical from angle 3, so we know that angle 5 is also 42 degrees. And then for angle 6, I'm going to use that angle 5 and the 68 degrees have to equal angle 6. So 42 plus 68 equals the measure of angle 6, so that's 110 degrees. Number 3, I have isosceles triangles. First of all, I know angle 1 is my vertex angle because it's made by my two congruent sides. So I know that the 35 and angle 2 are congruent. So I know angle 2 has to be 35 degrees. Figure out angle 1. 35 plus 35 is 70. 180 minus 70 gives us 110 degrees for angle 1. Now, since 2 and 3 are vertical, I know that 3 is also 35 degrees. This time, Angle 3 is my vertex angle because it's the one made by my two congruent sides. So to find angle 4 and 5, I know they have to be the same thing. So I do 180 minus the 35-degree angle for angle 3. That's 145, and then divide that by 2, and I get the angle 4 and angle 5 are both 72.5 degrees. Number 4, I need to use my exterior angle has to equal the sum of my two remote interiors. So 4x plus 50 equals 3x plus 15 plus 4x plus 5. So 4x plus 50 has to equal 7x plus 20. Subtract 4x. Subtract the 20. Get 30 equals 3x, so I know that x has to equal 10. All right, number 5, I can use some exterior angles. What I'm going to do is I know that this piece here has to be 60 because it makes the line with 120 degrees. And this angle over here has to be 55 because it's vertical. So then I know that the 60-degree angle, the 55-degree angle, and the 6x plus 8 make up my triangle. So they have to equal 180. So 6x plus 123 equals 180. Subtract the 123. So 6x equals 57. Divide by 6. I get the x is 9.5. And number 6, I know that this angle right here is 8x plus 4. So this time I'm going to use that these two angles have to add up to equal 130. 3x minus 6 plus 8x plus 4 equals 130. Combine my like terms. Add 2. Divide by 11. I get that x equals 12. I could have done, I know this angle has to be 50 because it makes the line with the 130. So I also know that 3x minus 6 plus 50 plus 8x plus 4 has to equal 180. Combine my like terms. 11x plus 28 has to equal 180. That's 50, not 30, sorry. So plus 48 has to equal 180, subtract the 48. And again, I get x is 12. So I can do this problem either way because I have a number for my exterior angle. In number 7, I'm going to have to use my isosceles triangles. Actually, no, I have to use my exterior angles. I know that 35, we'll figure out angle x. I know that these two angles have to be congruent. So I'm going to subtract 35 from the 180 to get 145, and then divide by 2 to get x. So x has to be 72.5. And then I'm going to figure out, I know that the x plus the 35 has to equal angle y. So 72.5 plus 35 has to equal y. So that's 107.5. And there's my answer. For number 8, I'm going to do the same thing. I know that these two angles here have to be congruent because the 57 is my vertex angle. 180 minus 57 is 123. Divide that by 2. And I get that x is 61.5. And then I have to add 61.5 plus 57 to get me y. So that's 118.5 for y. So there's number 8. Number 9, I need to construct an equilateral triangle. So what I want to do first, I get my compass. I put my compass point on A, pencil point on B, and draw an arc. I'm going to move this down to point D so I can copy this line segment. And draw an arc. Now, point O is where my arc intersects my original line. So here's O. Now, to make point G, I need DG and DO to be the same length. Well, I know that anything along my blue arc is going to give me something that's equidistant, or that's the given distance from D, but I need to figure out where the given distance from O is also. So now I need to make another arc. I'm going to make this one red. So I need to go over to O and do that same size arc. So I make my arc. So here's point G. So then, oops, here's my triangle. I know all these pieces must be congruent because I never changed my compass setting from when I figured out the length of AB. Number 10 is an isosceles triangle with the vertex angle is angle C. So here's my vertex. Now we know that the vertex angle is made by the two congruent sides. So since I have all side lengths here, these are all sides, then I know that BC must be congruent to AC because those are the two sides that make up angle C. So I know that 3x minus 2 has to equal 7x minus 5. Solve for x. And a little help myself. Okay. Negative 2 equals 4x minus 5. Add the 5 to both sides. So 3 equals 4x divided by 4. I get that x equals 0.75. However, I'm not done yet because it's also asking me to look for AC. So for AC, I come over and plug x in to 7x minus 5. Times 0.05 minus 5. And again, I'm going to use my calculator and use my store button. 0.75 stow x, and then 7x minus 5. I get 0.25 for AC. So there's my answer. For number 11, this time my vertex is angle A. So remember, when I am trying to figure out which sides I want to use, I always want to use my next door neighbors. I want to use the sides that are closest, that are right next to my angle. I don't want to use one across the street. So if I look at my vertex angle, my neighbors across the street are the 9 minus 2x. So that's the side I don't want to use. I want to use CA and BA because they're my next door neighbors. They're the ones that make up the angle. So x minus 3 equals 8 minus 27. Subtract the x. Add 27. 7x equals 24. Divide by 7. Now I want exact answers, so I'm going to keep this as my fraction and use my store button. So 24 over 7. I'll put parentheses around this. I want to store this as x. Then I want to figure out the length of BC. So I need, now I do need to use this piece. Because just because I didn't use it to find x doesn't mean that it's not still the same x value. So I want to plug in my 24 over 7 into 9 minus 2x. 9 minus 2x, because x was stored as 24 over 7. And I get 2.143, which as a fraction, math fraction, I get BC is 15 over 7. So I'm done. Number 12, I need to find the measures of the missing angles. Since they're all isosceles triangles, I need to pay attention to which one is my vertex angle. I know my vertex angle is made up by my two congruent sides. So in this first triangle, A is my vertex, which means I know that B and C have to be congruent. Well, I'm given that angle B is 52 degrees, so that means angle C also has to be 52 degrees. And then to figure out A, I add the two 52s together, and then I subtract this from 180 to get that. This first one for angle A is 76 degrees. Next one. EF is congruent to FG, so F is my vertex. I would get in the habit of labeling your vertex so you know that which one you're using. So I know that E and G are congruent. Well, I know G is 48, so E is 48 degrees. And then 48 plus 48 is 96. Subtract 96 from 180, and I get that angle F is 84 degrees. Next one, I know B is congruent to BC, so B is my vertex. So I know that A is congruent to C. Well, this time I'm given angle C is 42 degrees, so I know angle A is 42 degrees. 42 plus 42 is 84. 180 minus 84 gives me 96, so I know the angle V is 96 degrees. Next page. Number 13. I'm looking for angle EFG, so this green angle, which would be my vertex angle, because EF is congruent to FG. I need to find, well, it's the same thing as angle F. These are the same. Sorry, that's FEG. I need to find this angle, and then I need to find angle G. But I know that FEG, these two are going to be congruent because they're my fixed angles. So, easy way to find angle E. Well, I know it makes 180 degrees with the 110, so do 180 minus 110. I know angle FEG is 70 degrees. Makes angle G also 70 degrees. So then for angle F, 70 plus 70 is 140, and subtract 180 from that to get the angle F is 40 degrees. Number 14. I want to use a diagram at the right to find the measure of angle A, which is my vertex angle, because AB is congruent to AC. I need to find ACB and ACD. Well, ACD is 115. I know ACB and ACD make my line, they're a linear pair. So to find ACB, I do 180 minus 115, and that is 65. So ACB is 65 degrees. Well, I know angle B would also be 65 degrees. So to find angle A, I'm going to do 65 plus 65, which is 130. And then subtract that from 180 to get that angle A is 50 degrees. 15, you have 4 different answers for 15. I'm going to plot my points. -2, -2. There's A. B is 4, 3. Okay, so I know here's one of my sides. I'm going to make that be one of my congruent pieces. And then for the first, I'm going to use A as my vertex angle. If I make A as my vertex, then I know I need the distance from A to B to be the same thing as A to C. Well, how did I get from A to B? I went over 1, 2, 3, 4. Went over 6, and then up 5. Well, I want a line from A that's equidistant from AB to AC. So instead of going up 5, I'm going to go down 5 to get point C. So here's one potential point for C. So there, one potential point for C is the point 4, -7. To continue using point A as my vertex, I also could go up 5, and instead of going this way 6, I could go left 6. have another point C right there, in which case those two are congruent. When that point is the point -8, +3. Well, I also could use B as my vertex angle, in which case I knew I had to go down 5. So instead of going left 6, I could go right 6 to have point C over here. And that point would be the point 10, -2. And then my last triangles, I could go over 6 and then up 5 to have that be my point C. In which case this point would be the point -2, 8. There are my 4 different points. I just keep one, I pick my vertex angle, I pick one distance to be the same, and I do the opposite thing in the other for the other one. So 16, 7, -1 is A, B is 4, -3. All right, so far I have this line, which I had to go up 2 and over 3 to get from B to A. So if I use B as my vertex angle, well then, since I went right 3, I could go down 2 instead of going up 2 to have point C at 7, -5. I could go up 2 and then left 3, have a point at 1, -1. If I use angle A as my vertex, I could go up 2 instead of going down 2. And that would be the point 4, 1. And then I also could go instead I could go down 2, and then instead of going left, I could go right 3. And then I'd be at the point 10, -3. So there are all my potential points for number 16. Now I get to my favorite part. How to show that two triangles are congruent. Remember, I can only use one of these. Those are the only ways to prove triangles congruent. If I don't have one of those, I don't have any congruent triangles. All right, so let's look at what I have. In triangles, so I have SOY. That triangle. Well, in triangle SOY, I know I have a congruent angle. I know angle O is congruent to angle H. I know OY is congruent to HY. And I also have these vertical angles here. So I know that angle OYS is congruent to HYP. So these are an angle. So I know that these two triangles are congruent by angle, side, angle. And so SOY is congruent to PHY. Next one I know angle PSW is congruent to angle CWS. I know that side SW is congruent to side WS because they're the same side, because both triangles use this side. And then I also know that angle PWS is congruent to angle CSW. So if I look right here, I know that these two triangles are congruent by angle, side, angle, because I have two angles in the included side. So PWS is congruent to CSW. Letter C, I know that MN is congruent to PN. I know that MO is congruent to PO. And I also know that ON is congruent to ON because they both use it. So I know that I have a side, side, side. So MNO is congruent to PNO. By side, 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 because I have all three sides of one triangle congruent to all three sides of the other. Letter D. I know that WX is parallel to ZT. So then I can use some parallel angle pairs. So I know that angle XWV, no, sorry, angle XWV is congruent to angle TZV because they're alternate interiors. So that's an angle, and an angle. Using some vertical angles, I know that angle XVW is congruent to angle TVZ. So that's another angle. And the last thing I know is I know that XT bisects WZ. So that means XT splits WZ in half. So I know that WV is congruent to ZV. So I have that these two triangles are congruent by angle, side angle, because I have two angles in the included side. So I know that VWX is congruent to VZT. Letter E, I have a right angle. I know that KL is congruent to RS. With a right angle, I can also refer to this as my hypotenuse. And then I know that JL is congruent to TS, so I label that with an S. Since it's a right angle, I can also label it as an L. So if I look at this, just using the A's and S's, I have angle, side, side. But we know that never works unless it's a right angle, which we have. So this is hypotenuse leg, and JKL is congruent to TRS. Next page. Number 18. I want to identify how do I know these are congruent. Well, I have this side congruent to this side. I have an angle congruent to an angle. And I have these bottom pieces congruent. So I know that this is side angle side. In B, I know that these two sides are congruent to these two sides and these two angles. So I have angle, side, side, but I don't have a right angle. So these are not congruent because angle, side, side doesn't work. For C, I have my two sides that have one congruent mark on them. So those are congruent. On the bottom, I have those two sides are congruent. And then I have this middle piece that they both use, so this is congruent. So these two triangles are congruent by side, side, side. In letter D, I have the right angles congruent to each other. I have, sorry, I'm trying to figure out letter D since I what that letter is there, so I just drew over it. I have YX congruent to XP, so there's another side. And I have the vertical angles. So these two triangles are congruent by angle, side angle. Here I have PQS congruent to angle RQS, so there's an angle. I have the side they both use. And then I have PSQ congruent to RSQ. So these two are angle, side angle. With this one, I know FJ is congruent to JH. And I know both triangles use JG. So there's another side. But I don't know anything else, so these are not congruent because all I have are two pairs of sides congruent to two pairs of sides congruent. In G, I have some overlapping triangles, so I'm going to look at what I've got. I have an R, S, I'm going to label this O. And I have HMO. I know RF is congruent to HM. I know that angle F is congruent to angle M. And then I also know that angle O was congruent to itself because it's the same, because these are verticals. So another angle. So these two, so RFO and HMO are congruent by angle side. All right, 19. Use the word bank to complete the congruent statement and reason. Well, I have angle, I'm going to start from F. I don't have anything at F, but I do know FG is congruent to AC. I know angle G is congruent to angle C. And I know angle H is congruent to angle B. So here I have angle, side. So these two triangles are congruent by angle, side. If I look at my congruent pieces, I know G was congruent to C, so C has to go in the middle. H was congruent to B, so B has to go at the end, which means A has to go first. So ACB and AAS are gone. And then for B, I know WS is congruent to WU. Side UT is congruent to ST. And both triangles use WT, so this is another side. So my two triangles are congruent by side, side, side. And I know that STW, I went from 2 marks to no marks. So that's congruent to UTW. And now I'm on to number 20. All right, I want to plot all my points. P is 0, 0. E is negative 4, 0. P, E, T is negative 2, negative 3. And W is negative 3, positive 3. All right, I want to figure out, G, this is G, not W. I want to figure out, is PET congruent to PGT? Well, I need to figure out my sides, so I need to figure out PE. Well, PE is easy because I can just count it. And so that has a length of 4. I need to figure out PT. So PT, I had to go over 2 and up 3. So PT is be 2 squared plus 3 squared to give me the square root of 13. I need to figure out ET. For ET, I went down 3 over 2. 2 squared plus 3 squared equals 13, and then I square root that. And then I look at, I need EG. Well, for EG, I went up 3 and over 1. 1 squared plus 3 squared, 1 plus 9, which is 10. And then I need PG. PG, I went up 3 and over 3. All right, so then I look at my pieces. I know that PE is congruent to itself. So far, I have one pair of sides congruent. I know PT and ET are both congruent, but those are both of the same triangle. And I don't know anything else that's congruent. So these would not be congruent because I only have one pair of sides congruent. Because PT is not congruent to PG, and ET is not congruent to EG. So I can look at 21. 21, I have A is 0, 1. B is 0, 4. C is 4, 1. So here's one triangle, A, B, C. My other triangle, I want D at 1, negative 4. E needs to be at 1, negative 1. And I need to figure out point F so that ABC is congruent to DEF. Well, I like looking at my, so I have my horizontal piece. I have my vertical piece, but I need my horizontal piece. So I know that AC should be congruent to DF. So since AC is 4, then for F, I want to go over 4. So there is one potential point for F, and that potential point is the point 5, negative 4. So there is that triangle. I also could have gone to the left 4, in which case that potential point would be -3, -4. 22. Another one of my proofs here. I want to prove that triangle cat is congruent to triangle dog. CA has a length of 5. AAT has a length of 7. And CT has a length of, let's see, I went up 5 and then over 7. So 5 squared plus 7 squared, which is 74, and I square root that. And look at DOG. DO has a length of 5. OG has a length of 7. And DG, I went up 5 and over 7, so 5 squared plus 7 squared, which is 74, so I square root that. So I know that OG is congruent to AT, CA is congruent to OG or DO, and DG is congruent to CT. So yes, my corresponding distances are the same. So yes, triangle cat is congruent to triangle dog by side, side, side. All right. This next one is asking us for a couple different things. I find the distance is AB, so I went up 9. 9 squared plus 5 squared, 81 plus 25, 106, and then I take the square root of that. BX, I went down 5 over 9, so 5 squared plus 9 squared, 25 plus 81 is 106, and I take the square root of that. So I know that AB is congruent to BX. Now it's asking me for the slope of AX. Let's see. From A to X, I went down 3, 4, 5, 6, 7, 8, 9, 10, 11, 14. Went down 14, and then over 4. So that simplifies to -7 over 2. For the slope of BC, I went up 2 and then over 7. So are the corresponding distances the same? Yes, the two that I found are the same. And then it says, what do slopes tell you? Well, since I have -7 over 2 and 2 over 7, I know that AX is perpendicular to BC. So I know I have some right angles in here. I know those are both right angles. And I know I have the hypotenuse congruent. I also know that BC would be congruent to itself. So these two triangles are going to be congruent by hypotenuse leg, and ABC would be congruent to XBC. Next page, proofs. I want to mark off on my given information. I know that XY is perpendicular to AY. And I know BA is perpendicular to AY, and I know that XZ is congruent to BZ. And that's given to me. So my first reason, remember, is always given. Statement 2 says that angle A is a right angle and angle Y is a right angle. Well, how do I know that? Well, I know that perpendicular lines intersect at right angles. So for reason number 2, this would be perpendicular lines intersect at right angles. And then statement 3 says that measure of angle Y is 90 degrees and measure of angle A is 90. From statement 2, since I know angle A and angle Y are both right angles, then I know that since the right angle is 90 degrees, this is that right angles have a measure of 90 degrees. The next thing, it says substitution. Well, since I know that angle Y was 90 degrees and angle A was 90 degrees, then I know that angle Y is congruent to angle A. All right, now I have, says I have something else given. Well, if I look here, I have my given information up here. When I look over on my side, on my word bank, oh, I also know that Z was the midpoint of AY. That's what goes here. Z is midpoint of AY. Well, what does midpoint mean? Midpoint means that it gets split in half. So if the Z is the midpoint of AY, then I know that AZ is congruent to YZ. So this is the midpoint, separates the line into two congruent halves. If I look at my picture now, I have that my hypotenuses are congruent, and I have a congruent leg. So then this, what I tried to prove, comes down into here. So triangle XYZ is congruent to triangle BAZ by hypotenuse leg. 25. I know that MN is congruent to NP and NO bisects MP. Well, I know my first reason is always given. So write that in there. How do I know that MO is congruent to PO? Well, I look from statement 1. Well, I don't know MO is congruent to PO from MN is congruent to NP, but this word bisects here means that something gets split in half. So since NO bisects MP, I know that MO is congruent to PO. So this is definition of segment bisector. Or you can write a segment that a bisector splits the line in half. My next statement says that NO is congruent to itself. Anytime that you see something is congruent to itself, this would be the reflexive property. Now, when I look at my diagram, I know that triangle MNO is congruent to triangle PNO by side, side, side congruence. 2 more. I know that angle W is congruent to angle Z, and I know that XV is congruent to VT. And that is because this is the given information. Next thing says I know that angle XVW is congruent to TVZ. Well, I know that because this is vertical angles are congruent. Now if I look at my diagram, well, I have angle, angle, side. So my 2 triangles are congruent by angle, angle, side. The last one, for some reason we split it around. I want to prove that ACB is congruent to DBC. Let's look at what I have. I'm given that AB is perpendicular to BC, DC is perpendicular to BC, and AC, I'm going to draw these triangles out separately. I would always recommend drawing your triangles out so you can look at what you got. Okay, I know that AC is congruent to DB. And that's because this is given to me. My next statement says that BC is congruent to BC. Well, this is the reflexive property. Oops. Let me skip some steps in here. Since AB was, we know that angle B and angle C are right angles because our things are perpendicular. So this is hypotenuse leg. And there's your whole entire review. Look over it. Good luck on your test.